Hi guys, today we are diving into a Node.js project that you're gonna love. Or well, maybe not. Let's be real. This one is a bit on the boring side.
Boring!
But hey, I'm just being honest. But hear me out. This hit me out of nowhere. It's gonna be a PC specs application. Now, imagine you are not developers who already know every tiny detail about your PC, and suddenly this project actually makes some sense. Okay, let's dive right into this. To follow along and build this project with me, you'll need a couple of things on your PC. First, it's Node.js. You can download it from the official website. And I'm not going to walk you through the installation, it's pretty straightforward, and the link is in the description. But hey, if you're struggling, Google's got your back. Next, a code editor. I'm not going to tell you what to use, but here are a few options. VS Code, Sublime Text, Atom, WebStorm, Brackets, Notepad++, Vim, Emacs, NetBeans, Eclipse, IntelliJ,
One eternity later.
Dreamviewer, Bluefish, Kate, TextMate, Genie, and yes, even Notepad. But let's be real, I'm just joking. I'm using VS Code because it's awesome and I highly recommend it. Alright, now let's start coding already. First, open your code editor of choice and let's start a new project. I'm naming mine My Specs, but feel free to get creative. Next, we'll need to install a few dependencies. What? You thought I reinvented the wheel? No, obviously not. First rule, a good developer is lazy. Never write unnecessary code. I'm using these awesome libraries. Chalk for coloring console output. Boxen to make a box in the terminal. Figlet to generate ASCII art from text. Systeminformation to grab system specifications. Aura to add a loader spinner in the terminal. And oh yeah, I totally stole someone's ASCII art from the internet. No regrets. But jokes aside, shout out to JGS? Shout out to JGS. Whoever he is or whoever they are. Nice work. Okay, let's install the dependencies. To make it easy, I've included the terminal command in the description, so you can install all the dependencies in one go. You are welcome. After we've installed all of the dependencies, run npm init with the Y flag. This will initialize an npm project with the default values. No need to answer a bunch of questions. Now that the project is initialized, let's create a file called app.js. Now let's hook up our app.js file with the package.json file. In your package.json file, look for the script section. Under the test script, add a new script named start, like this. This means we can now start our project by simply typing npm start in the terminal. One more thing we need to do before diving in, add the following line to your package.json. Type module. This allows us to use the modern ES6 import syntax instead of the older require syntax. It's cleaner, more up to date, and just feels better to work with. I like to start by importing all the necessary dependencies. These are all of the libraries we installed earlier. Now that we have them set up, we can move on to building out the application. Next, let's write a function to get all the system specs using the systeminformation module. Since we are dealing with system information, this function has to be asynchronous. We'll also use a try-catch block to handle any potential errors because things can always go sideways, especially with promises. Inside the try block, we'll create a variable to hold all the information we want to know about the PC. This function grabs the CPU details, graphics, OS, memory, storage, and uptime. We'll create a specs object that holds all of the variables that we just created so we can print them out to the console. Outside of the function in the global scope, let's call the function. Now we can type npm start to the console. As you can see, it printed out a bunch of objects. These objects hold all the valuable information about our hardware and software specs. But raw data isn't very user-friendly, right? So the next step is to format this information into a neat string format. Now we go back to the getSystemSpecs function and delete the specs object. Instead specs we log OS and we start the application. From the operating system, we will need distribution, architecture, and the release. Let's create a spec strings object. I define the first property, which is OS, and then we are using template literals or backticks to format the specs into a readable string. Now let's check our work and log this string to the terminal. Great, we've got a nice string. The uptime property tells us how long our PC has been running in seconds. First, we have to divide by 3600 to get the hours. Since we are dividing, we're going to use mat.floor. The remainder gives us the leftover seconds, which we divide by 60 to get the minutes. Now let's log the uptime string to the console. It's 0 hours and 60 minutes. We have the OS and the uptime as strings, so let's continue with the CPU. Let's see what the CPU object consists of. Okay, so what we actually need from this is the manufacturer, the brand, also the speed max property, which is the maximum speed of our cores or threads in gigahertz, and the socket type. Now let's assemble this string just as the previous ones. I'm also using backticks here. And now I'm just using the properties we talked about. And here is our string. The next system information is a bit tricky. Let's inspect the graphics property. Add this to see what it contains. Now again, run npm start. Now it gives us an object which has two root properties, controllers and displays. Both of these are arrays. The controller is a list of all the graphics controllers like GPUs your system has. The displays shows the connected displays and their resolutions. This makes sense since a system can have multiple GPUs and monitors, so we'll need to loop through these arrays to get the info we want. So let's just do that. I will map through the graphics controllers array, and I will name each card GPU. Now for each card, we'll return this string. We'll need the GPU.model. And we will divide the GPU.VRAM with 1024 with the mathRound function, so we get how many gigabytes of VRAM our graphics card has. Now let's also test this. But first I have to prefix this with the return. So it actually returns this string. Here we go. As we can see, we've got an array. But there is one more important step. To separate the elements of the array, we have to join them with the comma, and we are done. We are almost done. We've got most of the strings, now only storage and memory are left. Storage can be a bit complicated, so I'll save you some time. You can copy the code directly from the screen or grab it from my GitHub repo. Link in the description. Here's a quick look. This will give us details about all storage drivers, their capacity and usage. So once you've got this, we are ready to move on. To show you how it looks, I will log it to the console. As you can see, all of my storage devices are joined together with a comma into a string. Now the only thing we have left is memory. We will make a string where we can see the total memory and the memory used. Both of the properties are given in bytes, so we have to convert them into gigabytes. Since there are 1 billion bytes in 1 gigabyte, we have to divide the values by 1 billion. 1E9 is a shorthand for a billion, so we're gonna use that. And with that, we have the last string. So let's log them together. Beautiful. We have the OS, uptime, CPU, graphics, storage, and the memory. As you can see, there is a total memory, or total RAM, which is 51 gigabytes, and 15 gigabytes is used currently. Here are all of the storage devices divided by a comma, the graphics controller, my CPU, the uptime, and the operating system. We are almost done with the hard part. And yes, this function actually took so long to write that I even had to get a haircut in the meantime. But we are not entirely finished yet. Let's dive back into something equally important, error handling. If something goes wrong while fetching the system specs, we want our app to handle it and provide useful feedback. So here's how we'll tackle that. We will add a console log, and we will log the message of the error. And we will call process.exit with the exit code of 1. This will stop the application and tell the user something went wrong. Now if we run our application, you'll notice it takes a while to fetch all the system data. To keep the user engaged and informed while the app is loading, we are going to add a spinner loader using the Aurora library. We initialize a spinner with a message like loading system specs. And we can add an emoji. And then we have to start it. Inside the try block, if we successfully fetch all of the data, then we add spinner.succeed with a message of system specs fetched successfully. Now in the edge block, if something goes wrong, we add spinner.fail with a message like failed to fetch system specs. This way our app feels more interactive and user-friendly. Look, if we start our application now, we instantly have some feedback. And success. The only thing we have left to do is to return the spec strings instead of console logging them. And with that, we are completely finished with this function. Now, if we start our application, we get the spinner, okay, right, but it's kind of boring. So let's spice things up a little bit. That's where figlet and chalk comes into picture. We'll have to make one more function. We're gonna have a title for our application. Now let's console log figlet.textSync. For the first argument, we have to specify a text, which is gonna be PC specs in our case. And the second argument is going to be an object with the horizontal layout full option. Under the function in the global scope before the get system specs, we call display title. As you can see, we have this ASCII art from our text, which is pretty cool. But something is still missing. Let's wrap this whole thing up with chalk.cyan. Our text has a cyan color now. Pretty cool, huh? But wait, we're still not done with the decoration. We are going to make our app even prettier. As I mentioned earlier, I stole... I used an ASCII art design from the internet. But feel free to get creative and design your own, or just skip this step altogether. It's important to use template literals to display the ASCII art exactly as we see it in the editor. Why? Because template literals preserve the line breaks and the formatting. Now we're gonna log the ASCII art with a chalk.magenta color. It's really starting to come together, and look, so much better. And with that, we can finally call it a day for this function as well. The last function is the most important step, because it'll display all of the specs to the console. It has one argument, let's call it specs, and it's going to be the return value of getSystemSpecs. We declare a variable for MetaSpecs. It's the same thing here, we also have to use template literals. It's time to form the final string. I'm going to use emojis, because why not? Emojis make everything better. To make our output even better, we'll use chalk green to give the text a fresh green look, instead of the boring default white. In this console log, we're going to use Boxen. For the first argument, it accepts a string. In our case, it's going to be formatted specs, which we just finished. The second argument is the options object. In this, we set the padding to 1, the margin also to 1, and the border style to round. Under our function declaration, we call display specs. Since we are using type module, we can use await in the global scope. And we call getSystemSpecs. Now, before we launch our application, it's important to delete the getSystemSpecs call under its declaration. Now we can start our application for the last time, finally. And here are our system specifications displayed into the terminal. Thank you so much for sticking around until the end. You are a hero, by the way. And I hope you guys liked this video. And yeah, this was my first video, but it's definitely not going to be the last. I plan to post at least one video every month, so yeah, stay tuned. Oh yeah, and about my desktop. I have this super basic Windows 11 wallpaper, and I thought, why not make it a thing? Here's the deal. Drop your wallpaper suggestions in the comments below, and the one with the most likes will win. We will do this in every video, and I will set it as a wallpaper for the next video, as long as it's not something inappropriate or something. By the way, my name is Balázs, and I absolutely love anything that is related to computers, basically. This channel is all about sharing that passion with you. So if you enjoyed this video, make sure to drop a like and subscribe for more content like this. And I'm also open to any video suggestions or video ideas. Thanks again for watching, and I'll see you next time. Peace!